Looks like Hyojin, you will have everything covered, and I'll just sit here.
Don't give me some pressure.
Hey, Winchan!
Hey, Winchan! Hey, I was
last minute. We were wondering if you'll be up yet.
Of course, I will be there.
yeah, I thought you didn't wake up.
Yeah, and then we the plan was to join like 15 minutes earlier, but so.
Oh, really?
Yeah.
I just set alarm that I will just get up like 1 minute, like here in this meeting.
Plenty of time. Mary Grace, it looks like we just went live as well.
Awesome. Happy Thursday, everybody, and welcome to the Koalas and Spark Ask Me Anything panel. Before we jump into introducing the absolutely stellar panelists we have here, I do want to just make sure everybody is aware of how to go ahead and ask questions. So as the name states, this is an Ask Me Anything. So the conversation will be driven by the questions that you all are asking in Meeting Play. So if you look at the Meeting Play platform, there's a Q&A tab just on the right-hand side of the screen. If you can go ahead and start to go ahead and put any questions you have in there for our panelists, anything that pertains to Spark, Koalas, any of the really exciting announcements that came out today, feel free to go ahead and do that. We'll aggregate the questions on the back end, and then we'll kind of address panelists and ask questions as we go. So before we jump into that, we'll do introductions really quick. So I'll start off. My name is Mary Grace Mesta. I'm a data science consultant here at Databricks, and I'll be the moderator of the panel for the next about half hour or so. And I'll go ahead and kick it over to our panelists to introduce themselves. Let's start with Connor Murphy.
Sure. Hi, so my name is Connor Murphy. I work very closely with Mary Grace and everybody else on this panel. So I'm a lead data scientist here at Databricks. I've spent a lot of my time doing machine learning deployment issues, and I've also spent a fair amount of time introducing customers to Koalas as well. So happy to be here, and maybe I'll kick it over to Marianne.
Hi, I'm Marianne. I'm the software engineer at Databricks. I've been working a lot on like SparkSQL, especially like SparkSQL performance at Databricks, and I'm based in Chicago, so it's getting kind of dark here. Yeah. So I'll just hand it over to Winchan.
Okay. Hello, everyone. I'm Winchan Fan, and I work for the Advanced team in Databricks. And I mainly work on SparkSQL and the Advanced community, like the review PRs and emails in the dev list and so on and so forth. And I'll hand over to Hyojin.
Yeah, I'm Hyojin Kwon. I'm a software engineer at Databricks. I do the open source things, and then I mainly work for Koalas, but I do take a look at other areas like SparkR or like some other areas. So yeah, hopefully I'm very helpful here. Yeah, that's all.
Awesome. All right, so I see we do have a few questions starting to roll in. So we'll actually start with one that pertains to the announcement from the keynote earlier this morning. So we all heard about how the Koalas library is going to be rolled into PySpark directly as a PySpark.pandas module. So I guess could someone on the panel address and help us understand what's the difference? Why is this going to be helpful for us moving forward, or helpful for data scientists or folks who are used to using Pandas and Spark or using Koalas? What's really going to be the difference here of merging the Koalas project into Spark?
I think I can answer these questions because I'm wearing Koalas t-shirt. So
That makes you qualified, or qualified, if you will.
Yeah. So firstly, PySpark users don't have to sort of install the Koalas by themselves. So it's sort of built-in support right now. So you install PySpark, and then you can scale your Pandas workload out right away. So that would be one of the benefits. And then Koalas will in perspective, development, the Koalas will evolve more rapidly with one of the biggest open source communities, Spark. In the past, Koalas have been developed by only few contributors and mostly Databricks engineers. But now we have a bunch of the smart Python expert, and then not only in Databricks but in the world, So I hope that I expect that it will be evolved very quickly, rapidly. And then to be more explicit, that you can you would expect more standardized support. Like, for example, there have been some gaps between Pandas and Koalas, and then because of the distributed computing. But like for that, the Koalas has like bunch of the Koala specific APIs to cover this gap, and then this kind of APIs will be like redesigned and then like audited by experts instead of only couple of people. Yeah. Oh, and then lastly, we're working on some more optimizations, because previously Koalas was the pure Python project, so it was sort of difficult to make that optimization between JVM and the Python side, because we had to write that code in Python only. But now it's together, so we can write some code like closely across the Java, Scala, Python. Yeah, so we could expect more optimization on that.
Yeah, maybe I might add one other thing to that if I could. So there's a lot of talk internally as to whether this API should be the default API for PySpark going forward, since it's a lot more intuitive for a lot of people who come from some sort of Pandas background. And so at a high level, like, we've tried to keep Spark as lean as possible. Back when we initially released Delta Lake, there was a conversation as to whether we should add Delta to Spark as well. And we decided that Spark is already a giant code base, and so we keep Delta as separate and have it integrate really well with Spark. And so as to whether Koalas will be the de facto standard API if you're writing Python code, I think that still remains to be seen, but it kind of speaks to the long-term trajectory of where we might wind up with Koalas.
Yeah, so it sounds like merging Koalas into Spark really is going to give Koalas access to be developed much more rapidly, just having access to a larger community, as well as some of those optimizations that Hadrian had spoke about earlier, as well as a more standardized support model. All right, we've got a couple other questions coming in. So does the panel have any tips on helping someone migrate from using Pandas on a PC to a distributed environment? So I don't know, Connor, if you've had experience since you've been in the field working with customers doing this. Do you have any advice for folks who are really comfortable working in a Pandas laptop environment, leveling up and scaling up to working in a distributed system?
It's a great question, and I think one of the biggest differences between using something like Koalas and using Pandas is the differences in indexing. Because indexing works very differently if you're in a Pandas environment versus if you're in a Spark environment. And so that tends to be the biggest friction point that I see with different customers, which is with a Spark distributed data frame, those are not indexed. Indices work differently when you're in a distributed environment because you have these different partitions of your data across the cluster. And so it doesn't work in the same intuitive way as you would expect with something like Pandas. And Pandas does rely pretty heavily on indices. And so there are a couple different ways of doing indices within the Koalas ecosystem. But all that to say is that tends to be one of the biggest, mindset shifts. But apart from that, a lot of what you're seeing within the Pandas API is going to work straight out of the box in the Spark environment. Koalas, I don't know if the engineers have a better stat on terms of the percentage of the Pandas API that's currently covered, but it is the vast majority of what you need. I don't know if, Wenchen, you have a better understanding of exactly how much is covered, but at the end of the day, the transition is relatively straightforward.
The API coverage, by the way, is around 83% something. Yeah. So
gotcha.
Yeah, we can just say like most of the APIs are already covered, because the leftover 27% less common APIs we didn't prioritize high. Yeah.
So will there ever be a point where we get to full 100%, or is there always still going to be a bit of a gap just because of the way things have to be distributed fundamentally?
The target is target is of course 100% for now, but I mean there are some like other APIs that don't quite make sense in distributed computing, like let's say like memory usage, for instance, because in case the Pandas is ego evaluation, so you can see the memory usage very easily right away. But like in Spark, it's lazy evaluation. So before the execution, it's sort of difficult how many how much memory will be actually consumed in the middle. I mean, without the execution. So that kind of API might not be explicitly implemented. Yeah, but yeah, basically the target is 100%.
Got it. Awesome. Yeah. So it sounds like, again, like we're at pretty high coverage, but again, merging this into Spark, hopefully we can hit those higher percentage of coverages more quickly, having access to that larger ecosystem.
Thanks for perfect summary.
We've got another question coming in. So there are several Spark functions. For example, the one that this user is asking about is the approx quantile function that uses a relative error term as input, right? Because Spark doesn't actually calculate the quantile, it's an approximate version. So will these functions in PySpark.pandas use a default relative error, or will they handle things differently? Or will things be handled differently in the PySpark pandas package for these types of functions?
We are currently thinking about matching the behavior to pandas exactly. So it might have a different behavior from the regular Spark functions. And then for Spark specific arguments like accuracy or things like that, that will be exposed as a extra argument. Yeah, that doesn't exist in pandas, but that will exist in Koalas function or APIs.
Got it. Okay, awesome. And then, so we've got another question coming in. So we've heard a lot of talk about a lot of different frameworks between Koalas, PySpark, Pandas, Spark. Do folks have any advice on how to sort of manage the change between all these tools of when should we be using Spark, when should we be using PySpark Pandas, when should we be using Pandas? What's sort of the criteria that folks should be looking for to manage like the flow across all of these different tools?
Okay, it's sort of a difficult question. Yeah, but I think the target, firstly, the target audience is a bit different, right? So in case of PySpark, the people I would recommend people like like engineers or like who build some like data pipelines, or like PySpark also support many other APIs like structure streaming that Koalas doesn't support. So I think I would recommend the PySpark for more like engineering or like building data pipeline or other general purposes. And for Koalas, I would recommend some people that the newbie in PySpark. So I mean, so they don't have to learn the old like legacy and existing the last of APIs in PySpark, but they can just just use the same knowledge in Pandas in a distributed computing. So I would recommend data scientists, Koalas a bit more. Yeah. Oh, and then by the way, sorry, one thing. So one thing is that we are also targeting of the what they call the seamless interaction between Koalas and PySpark. So like you can switch very easily. Just call one method and then it becomes PySpark data frame. And then just call another method and it becomes Koalas data frame. Yeah.
Yeah. So let me add a few colors here. So when you run Koalas queries, eventually it will compare to Spark queries. So that means we can always write a query with SparkSQL or with Spark directly. And for PySpark between Spark, then that's kind of a preference. So if you prefer Python, you can write in PySpark. But if you prefer Java and Scala, then go with Spark. So that's kind of some hint here.
Yeah, so it sounds like it's a tough question to answer because it's not a blanket statement, right? It's not if you're doing one thing, you should always be doing this in PySpark, or you should be doing this in Spark or Pandas or Koalas. It's really use case dependent. And I think a lot of it depends too on what's going to be the lowest barrier to entry to get into this, distributed environment, right? If you have a lot of data, if you're processing a lot, and you want to minimize, time to market or time to results, let's go ahead and pick the tool that's going to provide the least barrier of entry so people can go ahead and start, getting to work right away. All right, next question comes from another person in the chat today, and it asks about Numpy calculations. So sometimes there have been challenges with supporting some Numpy expressions in Pandas. So when there's been an aggregate, they're unable to use it with any Numpy calculations. So I guess how would Koalas handle this? Is it going to match more of the way Pandas is going to do it, or what is this going to look like?
Yeah, it's a bit. It's also. I know it's one of the limitation in Koala. So in case firstly, NumPy they expose some kind of interface called universal function. So the Koalas itself implement that. So like those functions are properly supported in NumPy, but I'm aware that some other APIs are not properly supported in Koalas. That one should be implemented in Koalas, or like or NumPy community has some kind of at a support of Koalas. But yeah, I'm aware of that, and then it's in the road, and then we are developing, and then it's in progress. Yeah.
Got it. So it sounds like over time these things would be supported.
Yeah, better. Yeah.
Mm-hmm. All right, next question kind of relates some of the stuff we heard in the keynotes on day one with some of the content we heard today, or just pertaining to Koalas. So someone asks, does joining two Koalas data frames go through the Photon SQL engine?
Yes, it does. But I mean, it does some kind of additional modification. But yeah, I think but basically it does, because you share the same.
I can take this one. So basically, everything gets compiled into SparkSQL in the end. But unfortunately, it really depends on what the data frames are involved with. So unfortunately, if it contains any UDF functions, like Photon is on the C++ layer, so we can't deal with UDFs at the moment with Photon. So if it contains UDFs, we don't really photonize it. But if it doesn't, it's just a regular query which can be photonized, which can go through Photon execution.
Okay, so it seems like one of the distinguishing factors is that UDF piece.
Mm-hmm.
Is that correct? Yeah.
Yeah.
Got it. Awesome. Thanks, Marianne. Another question came in about the maintenance of Koalas. And so, we heard about this change earlier. What does the future look like for the Koalas package? Is there going to be any sort of support, or is that going to be entirely deprecated, and folks will be required to migrate to PySpark.pandas?
Yeah, the Koalas will be deprecated, and it's actually a little deprecated in the GitHub repo. I mean, it will be in the maintenance mode still, and then we'll likely have some minor release, because the Koalas repo still supported the lower PySpark versions, and then people who use the lower PySpark versions, they wouldn't have a choice to use the Pandas package. So we'll still maintain, but it's sort of how do you say, in maintenance mode now, and we will have only maintenance release.
Got it. Okay. So it seems like everything will be continually developed on the PySpark.pandas.
Yep.
So what's the lift and shift like of somebody needing to do that migration of migrating from Koalas to PySpark.pandas? Is that as simple as just changing the import statement?
Mostly it will be yes, but I mean there might be some minor renamings. I mean we're in Spark community, we're trying to avoid any breaking change except the import change. But I mean, we'll see. And then we're also thinking about writing up a documentation for EEG migration. So yeah, users maybe can expect that the documentation in the Spark 3.2.
Mm-hmm. Got it. So shifting gears a little bit, there is a question about tuning. So any best practices for tuning PySpark with PySpark jobs that are using Koalas? Would it be any different than tuning just a regular PySpark job? Are there any different processes or best practices that should be followed depending on if you're using PySpark versus PySpark.pandas?
Yeah, the performance tuning, yeah, it will follow the most of the existing performance tuning tips in the PySpark itself. But we are adding some options specifically for Koalas. There are not a lot, but there are a few. And then those kind of best practices will also be documented properly, like the current Koalas documentation contains. Yeah. So that one you might not have to worry too much.
Mm-hmm.
So generally speaking, the way that you tune those pipelines is going to look very similar. it's worth kind of reiterating what you likely heard at the keynote earlier today, which is with smaller data sets, there's less overhead associated with Pandas, and so Pandas can oftentimes outperform Spark if it's working on a much smaller data set. And so that's one difference, is kind of toggling between when you want to use a purely Pandas data set and when you want something that's more robust that can handle a larger data size like Koalas. So that might be one of the few areas that you would add additional tuning. But beyond that, the same tuning process would exist, right? So is my data properly partitioned across my cluster? Are there joins that I can avoid? Those are some of the heavy hitters of tuning Spark jobs. And so all of those same things are going to apply.
Got it. Yeah. Makes good sense, right? That there's some sort of mirroring in the process that would be required for tuning in PySpark versus PySpark.pandas. Next question is about time series and geospatial support for things for koalas. So is there any planned support for geospatial use or for geospatial specific functions in koalas, or any of the time series functions within koalas?
Of course, if it's like how to say, if the Spark community will see if Spark community see the demand, and then if many people need it, and then if the community thinks that it's worthwhile, then we'll discuss and decide. It's not up to me alone. It's just up to the community. And then so far the Koalas itself is heavily dependent on the Spark itself. So my personal impression is that the Spark should have it first before Koalas has it. Yeah.
Sure. So as far as I know, so many databases already have this special time series of geospatial types and functions built in there. So I think Spark may also add it eventually if there are some customer requests.
Yeah, so since it's so driven by the community, what's the best mode of communication for someone who's really looking to have support for geospatial and time series functions within Spark and Koalas? What's the best, or the PySpark.pandas, my bad. What's the best way for them to communicate that?
Yeah. So I mean, I think there are already lots of bunch of the third-party library, but that works locally. So the Koalas package, or actually the existing PySpark Pandas UDF or other UDF, they can interact with those kind of library that works in locally. So I would use like Pandas UDF, or like there's some APIs like apply or transform that that allows you to use the Pandas data frame within Koalas package. So I would recommend to use like such APIs.
Yeah. And there's always, because this is an open source community, there's always the option of being able to do that, commit yourself as well, which would be a cool badge on your GitHub. Awesome. So next question is about indices. So indices are a huge piece of Pandas, right? I think folks who use Pandas every day love indices. So this question comes up of, does Koalas or PySpark.pandas support multi-level indices? And how are these handled if the data is converted back to a Spark data frame?
Okay, that's actually a very good question, because the multi-indexes is one of the trickiest things in the Koalas. And then because the PySpark itself doesn't support like either like index or like multi-index. The multi-indexes in Koalas are implemented by maintaining the multiple Spark columns internally. For example, like each level of the index has each Spark column, and then the Koalas maintains some kind of like theme metadata, and then that that makes the multiple Spark columns works as the multi-index. Yeah. So that's how it works, internally.
Perfect. Next question is about SQL and the difference between Koalas.SQL and Spark.SQL. Is there a difference? If there is, what's the difference? When should we use one or the other? What's kind of the protocol for communicating to Spark via SQL?
Yeah. So Okay, the first difference is that the Koalas.SQL can do some kind of string interpolation, like for instance, Python 3.6 added a F string format, but Koalas borrowed that format, so you can write the data frame in a variable to the SQL string, and then it works like string interpolation. So that's the main differences. And then another difference is that the Koalas.SQL can take the Koalas data frame as is, but the SparkSQL cannot take the Koalas data frame as is. Yeah.
So with the Koalas data frame, there's no need to create that temporary view, right, to convert back to SparkSQL like we saw earlier today in the keynote, correct? Is that what you're referring to?
Yeah.
Yeah, so it seems like, again, it's a lot of the string formatting, but the execution is consistent underneath the covers, right? So should there be any performance difference between using Koalas.SQL and SparkSQL?
The performance will be like almost exactly the same. Yeah.
Got it. Makes sense. Awesome. All right. Next question is about some other tools in the ecosystem. So as panelists, what do you all see as the most significant difference between Koalas and something like Dask?
Yeah. Dask and the Koalas say sort of pretty similar. And I know it's sort of, how to say, sensitive question-ish. Yeah, but I mean, different projects have a different focus. So like for Koalas, like many people choose it to leverage their existing Spark clusters. I mean, most of all companies already have like the Spark cluster running in their, in their company, and then many people already use the Spark cluster, and then Koalas just reuse it instead of set up another cluster. So
yeah, that's what we call unified analytics. Right?
Yeah,
I've heard of that.
It sounds familiar.
Yeah, and then another reason is that the API coverage itself, because up to my best knowledge, and according to the official documentation in Dask, they don't actually target the full API coverage, but Koalas does target the full API coverage. And then lastly, the Koalas leverage the bleeding edge technology in the SparkSQL, such as like full SQL optimizer or like code generation or like all other cool stuff in the Spark. So those Spark features have been developed, and they developed over multiple years by lots of people like Marianne mentioned. Yeah, so it's very fast and it's very performant. Yeah, so that might be the difference.
Got it. Yeah. So it seems like between API coverage and then kind of the way clusters are working and code gen happens underneath the covers is really some of those big distinguishers.
Yeah. So everything will be available in Koalas, like the AQE, yeah.
Yeah, that's actually a great point. So AQE, for folks who might not know, is adaptive query execution. And I guess, so Marianne, did you want to just quickly explain what AQE is and why it's such a great part of Spark? How it can be really, really helpful for performance.
Yeah. So like as I mentioned earlier, it's just like everything gets compiled into SparkSQL, and it's the engine that powers and optimizes all the other all the Spark applications, right? So and then like as the backend, so SparkSQL has this new cool feature along with Photon. And like our internal, Databricks runtime, so has Photon. So and then AQE does this query optimization in the middle of the query. So it just kind of, you don't have to fine tune your query individually anymore. So and then it just tries to give you the best query plan based on the runtime stats. And it works well with host stage codegen, and also as well as our Databricks runtime's new feature Photon, which is the execution layer. So all this together gets the best performance for Koalas SQL. Yeah.
And so is AQE implemented in Koalas right now, or is that still forward looking?
No, it's just it's the back end, right? So like Koalas, whatever, eventually gets executed in SparkSQL, and then SparkSQL has AQE. So it automatically gets all the benefit of the optimizations in SparkSQL, including AQE. Yeah.
Perfect. Awesome. Thanks for that really colorful explanation. We are counting down the seconds here, so we'll wrap up the panel. I want to say a huge thank you to the panelists and thank you to everybody